So hi all, welcome to this lecture series on solving previous year questions for GATE ECE, and here we will be solving the questions related to digital circuits. So welcome to the part 1 of this lecture series. So let us start with the first question, that is from GATE 2025. So the question is, a 3 input majority logic gate has input x, y and z. The output f of the gate is logic 1 if 2 or more of the inputs are logic 1, and the output f is logic 0 if 2 or more of the inputs are logic 0. Which of the following options is a Boolean expression of the output f? So question is like, I have a Boolean function f which is a function of x, y and z, okay, and given f will be equal to 1 when at least 2 of x, y, z are 1, okay, and otherwise it will be 0. Fine. So how to find the function f? So we know it's a function of x, y, z. So we can directly draw the k map of this function. Okay, so I have 3 variables x, y, z. Fine, and so 0 0 0 1 1 1 1 0. So this is the k map of this function f. Okay, and for any x, y, z, if any of these variables is 1, like at least 2 or more than 2 variables are 1, then output is 1, right? So we'll see here. So we'll write all. So for this, if x, y, z is 0 0 0, the output will be 0. If it is 0 0 1, it is 0 because only 1 1, right? If it is 0 1 1, it is 1 because 2 1s are there. If it is 0 1 0, only 1 1, so it is 0 again. Here it is 0, here it is 1 0 1, so again 1 1 1 1, so 3 variables are 1, so 1 1 1 0, again 2 variables are 1, so output is 1, right? So I can club this, I can club this, and I can club this. So what will be f? So starting from this one, so for x is 1, and for y z, the y I have 0 and 1, so that is cancelled. So I have x z. For this one, that is for this group, again x is 1, so x, and z is cancelled, only y I have. And for this one, third group, I have both x equal to 0 and 1 on, so I have yz. So f equal to x z x y plus yz. So answer is A. Okay. Now second question of today's lecture. This is again from GATE 2025. A full adder and an XOR gate are used to design a digital circuit with input x, y and z. The output is f as shown below. The input z is connected to the carry in input of the full adder. If the input z is set to logic 1, then the circuit function as dash with x and y as input. So this is a full adder, and x and y is the input, okay, and that is input bits, okay, and f is its output. So I have two number x and y, and f is the output, and I have one more input, that is z, okay. So what happens here? So suppose say z is 0, okay. So what if z is 0? I have input here x, and what is the input here? Input here is x y, XOR z will be equal to y, right? So f will be equal to x plus y, okay, and this is Cin, right? So Cin is equal to z equal to 0, okay. Now question is, when z is equal to 1. So what happens if z is 1? Okay, so here z is 1. What happens here? Y XOR 1, y XOR 1 is, it will be y bar. So this will be y bar. Fine. So here full adder output f will be equal to ex plus y bar. Okay, and what is Cn? So here Cn is equal to 0, right? That's why it is equal to x plus y. It is adding x and y. But here in full adder, when z is 1, the Cn is equal to 1, right? So Cn is equal to 1. So I have to add the bit 1 also. So what happens? Y bar is actually 1's complement. Okay, and adding this 1's complement with 1 will give us 2's complement. So it is similar to x minus y. So it's actually acting as a subtractor. Okay, so answer is B. So when z is 1, this full adder acts as a, or the circuit acts as a subtractor. Okay, yeah. Now coming to the third question, again it is from GATE 2025. So a positive edge trigger sequential circuit is shown below. There are no timing violation in the circuit. Input P0 is set to logic 0. So P0 is set to 0. Okay, and P1 is set to 1 at all times. So always P1 and P0 is set to 0 and 1. Fine. The timing diagram of the inputs SEL. So SEL is here and S is given here, right, are shown below. So here I have SEL and S values are given and the clock is also given. The question is to find the sequence of output Y from time T0 to T3 is. Okay, so if we carefully check here, we have two D flip-flops and two mugs. Okay, and input signal is given. So here if you carefully check how the D flip-flop works, it's actually a positive edge trigger circuit, right? So it's a positive edge trigger. So the output change at these positive edges. Okay, so what is the input at these positive edges? We have to see. Okay, so at this positive edge, okay, input SCL is 0. So SCL is 0 means, so I will take another color 0. So at this node SCL is 0. Okay, and if SCL is 0, what is the output of this mux? This mux will be 0 here. The output of this mux will be input at 0, right? That is P1, that is 1. Okay, and S is 0. So S here it is. Okay, S is 0. Okay, so what happens at this rising edge? Whatever is input here, that will be reflected at Q. Right, so I will get 0 here, I will get 1 here. Okay, and so what happens here at Q bar will be 1 and here Q bar will be equal to 0. Okay, so what will be Y? Y will be 0 XOR 1 is 1. So at this T0 I will get the value 1. Okay, because the same I will get till the next rising edge, right? Now at the next rising edge what happens? Okay, so here the select line is 1. Okay, so select line is 1. Here also select line is 1. Okay, so if select line is 1, okay, so please note this color. At this color it is at T1. Okay, not T1, I mean just before T1, the rising edge before T1. Okay, so at 1 what happens? What is output of the mux 1? That is it will be corresponding to S, and S here is 0, right? So I will be getting 0 itself. Okay, and what will be here? So the previous input is 0. right? So that same 0 will be available here. Okay, so in this rising edge the output Q will be this 0, so I will get 0 here and here it will be 0. Okay, so what will be Q bar? Q bar will be equal to 1 here and here the Q bar will be equal to 1. So 1 XOR 1 is 0. So at T1 the output will be 0. Okay, now we will see at the next rising edge. So I will take this orange color. Okay, so what happens at this rising edge? So here it is SCL is 1 and S is 1. Okay, so S here is 1 now. Okay, and SCL is 1. Okay, so when SCL is 1, so here in output of first mux will be equal to 1. Okay, and the previous input was 0 here, so right, so here the output of second will be equal to 1, sorry not 1, I mean 0. Fine. So what will be Q bar here? Okay, not Q bar, for the rising edge what will be? The value will be here 1, here the value will be equal to 0, right. So what will be Q bar? Q bar will be 0 and here Q bar will be equal to 1. So 1 XOR 0 is 1. So at T2 I will get the value 1. Okay, now for the last next rising edge, here again SCL is 0 and S is 1. So SCL is 0, SCL is 0, right. So SCL 0 means I will get here output as P0 and here the output will be equal to P1, P1 is 1. Fine. Now at this rising edge what will be the output here? So here the previous, so the current input is 0 and here the current input was actually 1, right. So I will get 1 here, sorry not 1 here, I mean 0, right. So I will get 0 here. So again the output here will be 1 and here output will be 1. Okay, so here I did a mistake. So here if it is 1, right, so at the clock cycle it will be here in the positive edge it will be equal to 1. So here it will be 0. So 0 XOR 1 is again 1. So I will get 1 0 1 1. So answer is A, 1 0 1 1, right. So okay, now coming to the last question of today's class. So fourth question, in the circuit shown below the AND gate has a propagation delay of 1 nanosecond. The edge triggered flip-flops have a setup time of 2 nanosecond, a hold time of 0 nanosecond and a clock to Q delay of 2 nanosecond. The maximum clock frequency in megahertz such that there are no setup violation is. So here we need to find the propagation, we need to find the maximum clock frequency. So what, how to find the maximum clock frequency? Will be equal to 1 by maximum clock time, right, so that it won't violate any setup or hold time. So which part of this circuit give maximum clock delay? That will be this one, right. This part will give the maximum clock time. So what will the value? 1 by, what is the maximum clock time? It will be the time, the setup time, right, plus setup time of the flip flop plus the clock to Q, TCQ, clock to Q of the flip flop plus the propagation delay of the AND gate. Okay, so TPDC, propagation delay of the AND gate. So we'll have the setup time as 2 nanosecond given plus clock to Q is 2 nanosecond and propagation delay is 1 nanosecond, right. So it is 1 by 5 nanosecond or it is equal to 0.2 into 10 power 9, right? Or in megahertz it is 200 into 10 power 6, or 200 megahertz. So answer is 200. Fine. Yeah, so that's all for today. Thank you.